So again, everyone, welcome to our instructor training class for Introduction to Networks, our first meeting for spring 2018. Today, I'm going to go over a couple things. First off, I will be going over, again, the basics of how the class works. I will then be going over some information on how you can go through the class effectively and easily, and also point out some differences between the way we do the class and the way you'll do the class in your own classroom. And then I'll actually jump into Chapter 1 and do a little bit in it, even though Chapter 1 is not due for another week or so, a little bit over a week. So again, welcome to our Instructor Training Center. I'm really glad to have you here. I'm going to hopefully I'm going to share my desktop. And I'll show you something that's very interesting for you. One of the things that I like to make instructors aware of, and one of the things we focus on, is that when you are part of the Cisco Networking Academy, you are part of a huge global thing. There are, I think, the last look I saw, 22,000 instructors right now in the academy, and so you're becoming part of a very big group. As part of that big group, one of the things we always tell people is this is a program that requires you to constantly learn. You'll see here that I've got understanding cybersecurity. I'm actually teaching a cybersecurity class and working to pass my CCNA cybersecurity fundamentals and CCNA cybersecurity operations exam. So I work hard to keep my certifications consistent and to continue to learn, because it is something that's very, very important. I want to take us back real quick just to Moodle, just to show you in your class itself, you really won't be using Moodle that much. The big thing was for you to do this introduction and then the course syllabus. Be aware the dates on the course syllabus, we are going to follow them roughly, but I will show you where your actual dates for all assignments will be, and they will be inside of Netacad. We also, if you want, you can use these particular items here to jump over to Netacad or NetLabs, but most of all, this is just to get your initial entry into the class, and also, if you would, every week or two, log in to Moodle just to make sure that we're, quote, tracking attendance. All of your real work will be done inside of Netacad and inside of NetLabs, and I'm going to go ahead and log into NetLabs too while I'm here. All right, so one of the things I will show you about NetLabs, and this is a really important thing, if you do get this Java was not detected, Chrome no longer loads Java as part of its the browser itself. So when you click continue, and it will then ask you to run a test, you must run this test. If you skip it, NetLabs will not work. So when I click start remote access test, you'll notice that a JNLP file downloads. I click and open it, and I click later. It's telling me my Java version was out of date. And then it will pull up a security warning that you just have to go, okay, yes, I trust content from NetLabs. Yes, run this Java app. And now it has gone out and run an actual Java applet test so that your labs will work. We'll talk more about NetLabs in just a minute. But again, Moodle, landing page, do the first assignment. Then after that, try to log in every week or two, just so I have a history of you being in the class. Our primary area that we will be working from will be your class itself. Now, this is your class, and you will see that on the right-hand side over here, you will see the to-do list. These are people who have already turned in some assignments. By the way, I am amazed. This is the fastest I've ever had people start working on assignments, which is a really important thing. I will tell you there's actually a method to my madness as to why I did not immediately put you in Netacad. What I find is, especially with my class, I need you to first do the Moodle assignment. If I drop you in a Netacad, many times people won't go do the Moodle assignment, and then I have to drop you because you didn't do the Moodle assignment. So I don't put you in Netacad immediately. I make you do the Moodle assignment, then I put you in Netacad. But then I've had some folks really jump forward and start working, which is really, really good. I want to show you quickly, as I did in the introduction, to download Packet Tracer before you take the pretest. I really should have done that before, but the pretest will actually work without Packet Tracer, but you do need Flash. But you need to install Packet Tracer, so go to Student Resources and download and install the latest version of Packet Tracer. Right now, let's only download 7.1. There is an issue with 7.1.1. Right now in spring 2018, let's download 7.1, not 7.1.1. Download it and install it. If you've already downloaded and installed 7.1.1, you can uninstall it, reboot your machine, and then install 7.1. So that is available under the student resources on the main page of our class. You also see on the bottom right-hand side the calendar. If you click on View Calendar, you're going to see all the due dates for the assignments that you have. Now, I want to stress something. Do not freak out. We do not allow freaking out in this class. Oh, by the way, real quickly, this is me. I am a guy. So some of you thought you were going to have a female instructor. I'm not. I'm a guy. I blame my parents for both being a guy and for my name. So this is me in my junky office behind me. But I usually keep the camera off just because it reduces the amount of bandwidth you need for your side. But it is, you can actually say you have seen your instructor. It is Blue Monday. So on Mondays when you see me, I'll have on a blue shirt. If you have other classes with me, the guys in our department wear different colored shirts on different days just so we don't have to think about what to wear. You will see, though, over here in this particular calendar, all of these assignments. Do not freak out. I will state that a second time. These due dates are not set in stone. If you do not get the Chapter 1 exam done on the 18th, I am not going to give you a 0. Get it done on the 21st, that's fine. Same thing with the labs. If you don't get them done on that exact date, I'm not going to give you a 0. I will tell you this. If I don't give any dates at all, what I have found is that most people will be like me, and that is they'll procrastinate. So I want the dates there so you're at least being prodded to work. But if you don't hit the exact date, I'm not going to have a heart attack, and I'm not going to give you a 0. Also be aware, I know there's a ton of labs in this class. You've got a good amount of time to do them. There are times when we get down here and there's 6 or 7 packet tracers. If you do not do every single packet tracer, I'm not going to have a heart attack there either. It will always be best for you to do all of them for your own good, and I do have my students do every single one of them. But I also realize, folks, that you are instructors and you are working 40 hours a week. So, try to do the best you can. But again, I'm not going to have a heart attack if you miss a single due date, or if, let's say, in Chapter 6, you only do 4 of the 6 packet tracers. Not a huge issue there. Just be aware that they do help you, and they will definitely help you when you go to take your exam or your particular course. Now, to get back here, you can go, the only really easy way is go back to My NetAcad and then go to your class itself, which is right here. Inside the class, the most important area is the modules area. And this area is where you will see all of the different chapters and information. So you can see here, if you're first time in the course, you should have done this. Here's the pre-test exam, which was due February 11th. Again, if you don't get it done by yesterday, no problem. Just take it when you can. I know there's some new people just came into the class, and that's not a problem. One of the things to be aware, and this is something you'll learn as you start teaching these classes. Another reason why I waited to turn the pretest on is I need all of the students to be in the class before I activate exams. If I activate exams and you're not in the class, and then I add you in the class, I had to go back through and activate all the exams for you. So be aware that's one of the reasons I waited a little bit longer to activate the pretest instead of just doing it immediately and having it active when you dropped into the class. You can't do that. Students must be in the class first before you activate exams for them. And we will go over activating exams and using this system for your students as we get further along in the course. Right now, we're just going to get you settled in and getting you ready to take the course. So our basic format will be for you to launch the chapter and read the entire chapter. You will then go into each packet tracer assignment, click on it, and go to the packet tracer. Now, as many of you become aware, there are some packet tracers, such as this one right here, Packet Tracer Help and Navigation Tips, which really do not have you do anything that is graded. It is simply a packet tracer that is what I call a look and see packet tracer. So as I mentioned in the detailed orientation, some of these packet tracers you may just have to upload a single Word document or notepad that answers questions, or if you do have a PDF that is a form fillable PDF, you can fill in the answers to the questions with it and upload it. I still want you to upload your .pka file, say with your name, just so you get into the habit of doing that. Okay. So again, this is a look and see packet tracer. When you do check results, it says it's locked because there's nothing to check. It's just asking you to go through and perform help and navigation to get you familiar with packet tracers so you'll be ready to use it with later labs, okay, or later packet tracers. So go back to modules. Labs, however, are different. These two labs are just written labs, okay, so they do not have a corresponding NetLabs lab with them. As you move down and get into other labs, you will see labs that, for instance, here's a switch management address. You'll see that this lab has a switch and a PC. So if I go out to my NetLabs, I can actually schedule, and Brandon, you're on top of the list. I'm going to use you as an example, sorry. Okay, so Brandon's going to do configuring a switch management address. And he's wanting to do it right now, so he's going to go out here and pick pod 4. Right now there are 4 pods, so be aware that those pods can get fairly busy depending on the weekends and those types of things, so make your reservations accordingly. And then you can see that this pod is now in the process of booting up, and it takes a little while. It takes 5 to 10 minutes. So these labs that you can download Word documents for, okay, you can do. Now, here's one of the things I want you to be careful of. The lab as written right here in the curriculum is written for you to use it if you are sitting in a classroom. So this lab, as it is written in this document, expects you to sit down and have a switch and a PC. So it may tell you to connect your console cable into, establish a console connection to the switch from PCA, which in the real world, you would connect a console cable to PCA, connect it to the console port on switch 1, assign the terminal information. By the way, when you read chapter 2, this will make a lot more sense, and you will do that. In NetLabs, we can't connect physical cables. I might actually jump into Tim's lab. Tim will get mad at me. But so in other words, if I want to go from this PC and I want to get into the console of S3, I can't connect a cable. So the labs inside of NetLabs have been rewritten, and you'll see they've been updated for use on NetLabs. This happens to be a CCNA security lab that's been rewritten. All right. So when a lab asks you to access the console of a device, all you have to do is click on that device and then open that JNLP file, and you will get, once you continue to hit continue, and Java is of the devil, just to let you know, but you will eventually get to a console on a switch. Okay? So the lab is rewritten inside of NetLabs for the lab that you're doing. So when I do show lab content, you'll see it's been updated. So you'll see it doesn't ask you to connect the console cable. So when you're actually inside of NetLabs, you need to open up the content inside of NetLabs and make sure that is what you're using to walk through and do the lab. Otherwise, you're going to be very confused when it's asking you to connect cables, and you're going, how do I connect cables inside of NetLabs? And you can't. So it basically will tell you here, I'll click on switch 1, and guess what it does? It opens up switch 1, and at this point, switch is actually in the process of still booting up. This is it loading the iOS. Again, this is one of the great things about NetLabs. It is not a simulation. It is real gear with all the quirkiness of real gear, which can be great and can be a little bit aggravating at times. Excuse me. See, this is a Cisco 2960 running land-based K9 version 15.02. Going through all the tests, initializing flash, and going on through its post power on self-test. So what I would do is do this lab using this content, but answer the questions using this Word document. So when I get down in here, and it asked me at the bottom, eventually there's a couple questions down there, some pinging you got to do and some other things down here. It says, why must you use console connection initially configure switch? Why not connect the switch via counter SSH? You can download this Word document, answer that in blue, and then upload it into the upload for that particular lab, which is right here. So every packet tracer you complete and every lab you complete has a corresponding upload. By the way, even my own local instructors didn't realize these links and these uploads are not something that happen automatically. This is an entire course shell that I created with all of these assignments, with all the upload links and all of those. What I will do once we get further along and you get further into the class, I will actually send you links to these and teach you how to upload these into your own courses so that you don't have to spend the 2 days creating all these things like I did. You will thank me, trust me. Right now, before we go any further, are there any questions on what I have shown you so far, or the format of the class, or how things are going to work in the class? Unmute yourself, type it in chat, any of those.
I just have the one question on NetLabs. How is that actually something that's graded using through NetLabs, or is this like we actually fill in the Word document?
Okay. The Word document that you upload lets me know you have completed it in NetLabs, and also lets me know that you've answered the questions in the lab. Here's one of the really cool things about NetLabs I can do. I can go in, and what I do is I go into a class, and I'm just going to grab one of my old classes. Actually, I'll grab one of my own classes and grab myself. That way no one can say I'm showing their information. My student account's done 187 labs. I can actually look right here, and I can see every single command and everything that you've typed in.
Okay, that's just what I was wondering, because I have access to all the physical equipment. That was all I was really wanting to know.
Right. And I will be honest with you, if you want to do some of your labs on physical equipment, I have no problem with that whatsoever. I would like you to do some on NetLabs just so I can see it and know that you're actually doing the labs. But if you have physical equipment in your lab and you want to use that, I have no problem with that either.
That's fine, because I normally just go in and have them copy the config and throw it in a notepad and store it in Google Drive, or Classroom. But yeah, that's actually, I like that.
Oh, yeah, that's really what I like about it is I can go in here and let's say somebody had a problem. I can look at the final config, and I can actually, in this case, I'm looking at the, let's see if R1, if I put anything on R1. I didn't even configure R1 here, but this was an ASA lab, so it's a little different. But you can see how I can actually look at what every command was put in, and I can actually look through and say, oh, guess what, you forgot to do this. So it's nice to be able to do that, and it's something that is actually a little bit hard to do versus some of the other labs that we've done before, because I mean you don't get a chance to see everything, especially when you can go in and see what they were typing. Yeah,
that's what I like.
Yeah.
You see how many times they messed up.
Yeah, you can see if they messed up. And
how many times
I get so tickled at students too, because I can go in here and they say, yeah, I did the lab, and I click right here and nothing at all was typed. And I'm like, no, you didn't, and you just went in the lab and did nothing. And you'll also see if it's not attended, if the schedule don't go into it at all, it will say not attended. And it will tell you how long you spent in it. So, there's sometimes you're like, there's no way you did that lab in that amount of time.
That, or if they just copy and pasted the config.
Yeah. Which sometimes, if they've done it in Packet Tracer, if they've already built it out in Packet Tracer and then they come in and copy and paste it in, I can see that and I can know. But I like to see their work inside of there. It's kind of like, it's kind of like math questions, seeing your longhand work instead of just the answer.
I just have students that like to go into Classroom and copy somebody else's, and they don't realize it actually shows the audit trail.
Yeah. Oh, yeah. And you're like, I have a joke that I tell my students. I said, if you're willing to, I tell them if they cheat, they go to hell. So if they're willing to risk their immortal soul to cheat and pass the class, go for it. They laugh pretty good about that, and then they go, oh, okay, wait a minute. All right, any other questions about the way this course kind of works? Folks, it is a lot of work. I'm not going to lie to you. The good news is most of you, if you've been in networking at all for any time, some of this will be just review. You know what the OSI model is. You know what Ethernet is. It'll fill in some details that maybe you haven't seen before, especially when we get down into the IP addressing with IPv6. There'll be many things you haven't seen before, unless you've just been working with IPv6. But then it gets all the way down and actually building a small network. So by the time this class is over, you actually have started to configure and maintain and build Cisco networks or networks using Cisco equipment. Yes, this does focus on Cisco equipment, but I guarantee you, if you can build a small network with a Cisco router and switch, you can build a small network with any kind of router or switch. The concepts apply to anything. So that's a really neat thing about this class. The other neat thing about this class is this is the exact same materials your students will go through. So if you take the time to go through this and really dig into it, when you go to teach it, you will not have to spend as much time prepping. You will be ready to teach the class, which is another good thing. Did someone have a question? I think I may have cut somebody off. No questions at all? You know all, see all, hear all, or just too scared to ask?
I did have one last one. How much will we hit on SDN, or for the software-defined networking side, since that's new?
Very little in this particular section. That's out in the Connecting Networks class, which is the final course in the 4-course sequence. We also, another thing that we do have, Brandon, we have a series of emerging technology modules that Cisco, in fact, I may be able to show you, that just came, those are just coming out. Let me see if they're in here. They may not be listed here yet, but there are some new modules that are coming out that are, they're not here yet, that are going to be actually working with the DevNet. I don't know if you've heard of the DevNet group, but working with DevNet, and there's a course on the REST API and Spark, and there's another one on software-defined networking in Python. So those are two that will be rolling out in the next 3 months that will be available that you can drop in. Now, I suggest you drop those in, you know, second year. I don't know where you're at a university or at a 2-year school, but if you're at a 2-year school, it would be something you drop in probably their final semester after they've gone through most of their networking and programming. If you're at a university, it's probably something that would be late sophomore year, early junior year.
I'm in a high school environment.
Okay. Well, honestly,
if I have that one bright,
yep,
really bright one that hits it, that's when, because we were talking about it today. Because I was like, yeah, all the iOS commands eventually will be this nice, beautiful GUI that we've heard about for a decade now.
Yeah. Well, and the other thing that would be really good for them, honestly, in this course catalog, is to get them to take the Linux Essentials class. This Linux Essentials class, this NDG Linux Essentials, does not require you to have to take any instructor training on my end, but you can put your students into it and let them do Linux Essentials, which is really getting them to the point of being LPI Linux Essentials certified, which is very, very big in the, well, Linux is big in the industry right now. So, all right. So I'm going to go back into our intro course, folks. And I'm going to go ahead and launch the course. I'm going to launch it from right here instead of going in. You'll see the different, here's all of our chapters: explore the network, configure and operate network operating system, all the way down through our build a small network. And you'll see we're doing, basically at this point, we're going from the physical layer up through data link, network, network layer, and then we're down in transport and applications. So we're doing the at-in, the TCP/IP model we'll talk more about. But I'm going to go ahead and get us started and look at just a welcome, exploring the network. You will see that the basic interface for the class includes the following. You've got forwards and backwards, pretty simple. You've got the ability, if there's a standard graphic or anything that's is actually transcribed. You would have it here. You can bookmark. You can click on the course index, and you can see all the packet tracers associated with chapters and all the labs associated with chapters. You also can quickly find videos that are in each one of the chapters. Okay. You can go to the course index again and go back and jump in that chapter 1. So as we go forward, you can see that this very first chapter is pretty easy. It's just, what is a network? What's the basics of a network? I don't use these a lot, but especially if you're in a high school, here's a really good thing, and it's really not a bad thing either. It's like an opening class concept, and they say, draw your concept of the internet. So it's an activity that your students can do. I don't have my instructors do it, but I know a lot of instructors who do it, and you go in and you just have them actually draw a network and see what they already know. I also like to ask my students examples of networks that they may already know. You think about it, simply driving into work is an example of being on a network, because the roads are a series of networks. If you look at when you go to the bathroom and turn the water on to wash your hands, really the piping and everything that's used to get water to the sink is very similar to what we use for a network to get information to a computer. And so they have all types of things here. Obviously, they have some videos. Some of this is a little bit of a, I have to warn you, marketing. Okay, there's the marketing.
Welcome to Grand.
Kind of cool, though. And they do have transcripts, so you can actually go in and look at the transcripts of the videos for ADA compliance. Okay. Sorry, my phone rang, folks. Here's the Internet of Everything, where they're starting to talk about IoT and how everything is connected. It's really kind of scary how connected we are. If any of you are Google users and have had Google Maps send you a summary of your month and where you've been that month, it's really, really scary. I was in Canada back in January on a dog sledding trip and was, on the dog sled, riding around back in the backwoods of Canada, and my phone kept dinging with emails. It's kind of funny. We were in the middle of nowhere, and my phone was still picking up. And so it's really a totally different learning, just like this. I mean, I'm in here watching the Cisco, learning on this. How many of you are familiar with Safari? Any of you know what Safari is?
You mean Apple's wonderful browser?
Nope, not that one. It is, let me see if I can actually find it without pulling. Safari is a monthly service that you can subscribe to that lets you have access to all kind of books and training courses. Well, inside of here, and I mean, there's books for everything, and it's not cheap. It's like 50 to 40 bucks a month, but you'll see that here's a bunch of official cert guides that are in here. All types of things, CCIE, routing, switching. I've been going through the CyberOps Fundamental course. So I've been going through it, and it's totally free. Well, not free, but it's part of my my subscription. So it's really neat. But, that's a totally different way to learn. That's something that didn't exist when we were growing up and going to school. So students today are very different. They also think because they own a phone, they know everything there is to know about a computer, which is funny. I do have a funny texting story. When we bought smartphones about probably 6, 7 years ago, I don't even remember how long ago it was. It's been a good long time, probably 8. When I got my wife her first smartphone, and we went to talk about the cost of the smartphone, and they said, well, you have to pay for a texting plan. My wife was like, I am not paying for texting. And now she texts all the time. I mean, it's just her preferred mode of communication since she's an introvert. So I listen to a lot of podcasts, a lot of web things. You think about today, you need to fix your refrigerator's ice maker. What do?
YouTube.
I go to YouTube, exactly. In fact, I have fixed my ice maker on my refrigerator by going to YouTube, putting in the model number, and looking it up. I mean, it's really crazy what you can find today. You find a lot of junk, but you also find a lot of very useful information. So, support the way we play. I've got an Xbox One, actually an Xbox One X, and just the whole fact of the internet play and being able to get online. I don't go, I am now the ultimate in lazy because I never go buy games at the store. I just download them. On top of that, I've gotten to where I play these miniature games where I build little plastic miniatures, and I look at the cost that would cost me to drive over to Charlotte, which is about an hour away in time and all. And so I just end up, but when I buy something, I just ship it to myself. My wife claims that I personally keep Amazon in business. It'd be funny because I probably get 2 or 3 Amazon packages a week. So there's your first lab. Go look at your looking at your collaboration tools. Now, looking at different network sizes. One of the things that when we look at networks, first off, I tell people that networks need a couple things. And one of the things, a network always needs, first off, something to share. You know, there's got to be a reason for it to exist. In the old days, it was sharing these big high-dollar printers, these laser printers. Today, it can be anything. It can be sharing email, videos, text, you name it. But a network's got to have something to share, so it's got to have a reason to exist. It also needs to have a media or a medium. And I put that on there because the media could be a copper or fiber. It could be an RF. It could be a radio signal. And a radio signal would be a medium, not a media. So you need one of those two. And then last, you need a protocol. You need some common language. Common, if I spell it right, language used by host. By the way, I used to be a really, really good typist. And then actually in 1 month, a little bit over 1 month, it'll be 2 years since I got hit by a truck while cycling and was paralyzed from the neck down. Thank goodness I can walk now and I can move, but I still don't have full use of my legs and arms. So if you see me type or hear me utter a profanity while typing, it's because I'm getting aggravated with my hands. But these are the things that a network must have in order to exist. Now, when we talk about different sizes of networks, we've got SOHOs, small office networks, or, you know, you really think about, let's sit down for just a second, and I want you to spend the next 15 seconds thinking about the number of devices in your house, and then just put in chat the number of devices in your house that have an IP address or connect to the internet. So let's see, tablet, 2 phones, Xbox, 2 computers, laptops, you know. I would say, Matt's saying 16, that's probably pretty good, 20 or more. Okay, that's, Matt, did you consider your DirecTV or your other boxes? Did you put those in there too?
Yeah, all of that, exactly, yeah.
Cameras, you know, I've got, how many of you have heard of the Blink TV or Blink cameras? If you haven't heard of Blink, it's an amazing system. You need to look it up. They're little cameras that actually run off AA batteries, and they're wireless. So they're super simple to install. Yeah, so I've got four of those, 5. Yeah, I've got well over 20 devices. Now, that's just in our houses, folks. Now, you think about it. You know, when I allow it. That's a good one. When you think about a home having 20 or more devices, you know, 10, 15 years ago, we considered a small office network 10 to 20 devices. Now, we've got that in our house. So networks are growing tremendously. So small office home networks, SOHOs, which are a little bit bigger. LANs are local area networks. Now we talk about when we talk about local area networks, okay, we talk about a LAN, and we talk about being a local area network. We also always teach my students that think of it as a limited area. Okay, so usually within a small geographic area, could be a campus, could be whatever. Now there is actually a campus area network. There is a thing called a CAN. We don't use that term very much, but that is a term that's out there. We also know what a WAN is, right? What is a WAN?
Wide area.
Wide area. So there are no limits, no geographical limits. How many of you heard of a PAN?
Bluetooth.
Yeah, Bluetooth. That's a personal area network. I give you a great example. I told you I got hit by a truck 2 years ago. I was riding with a GPS that connected to my phone that was tracking where I was at all times. And when I didn't return home, my wife pulled that up and saw that I had been sitting in the same place for about an hour and a half, and then she knew something had happened. So these personal area networks are getting more and more important. If you wear a heart rate monitor that connects back to a strap on your chest that is doing the heart rate, they even have things now that will measure your strides for the number of strides you take while running to give you an idea of how fast you're going. So those personal area networks are really growing. Anybody watched Altered Carbon on Netflix? If you haven't seen that, you need to just take a peek at it just to see some of the technology things they're doing with personal area networks that are built into basically into your eye, which is a really kind of a neat thing. Neat and scary at the same time. But here's the thing that's amazing. I read this week, obviously about, say, Curtis and Tom have watched it. Curtis, but I read this week about some artificial limbs that are being covered with this new type of skin that can sense heat and can also sense synthetic skin. It's not, obviously not real, but it's synthetic skin that can sense heat and pressure. So to be used to help people with prosthetic limbs not crush, a cup they pick up when they go to pick up a small paper cup. It'll realize not to crush that. So some of the changes coming about in technology is simply phenomenal. And again, most of this you already know. What's a client and server? A client receives services from the network or from other hosts. A server provides services to another host. Now, in certain networks, you can have a device or a host that acts as both a client and a server, and that is most often in our peer-to-peer networks. Peer-to-peer networks are one type of network. They're easy to set up, they're cheap, they're less complex, and I don't know why I just went over there. But they are not as secure because there's no central administration, and also you have to do security on every single device. They're not very scalable either, so we say peer-to-peer networks, no more than about 10 hosts. So here we have an overview of a component. They talk about devices, media, and services. Services would be that thing I talk about, something you need to share. Media is the media or medium that you go across, and then devices would be the host or the intermediate devices. I like mine better as far as the device, saying you need a protocol versus this, but they use devices, media, and services. And be aware that's what will be on the test for the chapter. So just a little warning there. Okay. And then when they say network services and processes, they're looking at rules and protocols. Now, one of the things you'll realize, they're end devices. Those are devices that you actually interact with in order to access the network, and then they're intermediate devices, which are devices that help you traverse the internetwork or the network itself. And that's what this goes through. By the way, question? Okay. Now, I know this is not extremely exciting, this little flash animation here, but look, flash programmers got to eat too, okay? I mean, we gotta help them out. So this is, make sure that you do watch these, because it really does sometimes help, especially later on. A lot of the flash animations do a great job of showing you how things work. Intermediate devices, wireless LANs, multi-layer switches. That's a layer 3 switch, by the way. A LAN switch, which for the purposes of the CCNA, we consider a LAN switch to be a layer 2 device. All right. Firewall appliance and then routers. So a couple devices we'll see over and over. Here's our network media. Again, copper, fiber. We'll get much more in detail on this. Geez, I muted you because you heard you clinking your plate. Different types of media. how do we choose one media over another? Well, we'll talk a lot more about it, but a lot of it has to do with attenuation, which is signal loss along the line. It has to do with crosstalk. Are you going to have it inside of an area where there's a lot of electromagnetic interference? How far do you need it to travel? You know, we've been trying to figure out a way to get fiber from one of my coworkers' house to my house, and we're trying to figure out how we can do a ditch, ditch switch that will go across about, half a quarter mile, but we haven't been able to figure it out yet. So all of those will be items to consider when you look at your network media. Here's some of the representations. These are just common icons we'll be using. Okay, get used to these because you will see them over and over and over in Packet Tracer. You will see them in NetLabs. You will see them in all of your readings online. There's a NIC, Network Interface Card, which is a layer 2 device we'll talk about. There's a physical port, okay, connector, and then the card itself, which is a layer 2 device. This is really a layer 1 transceiver and then a layer 2 card. Physical topologies versus logical topologies. Here's a physical topology showing exactly how items are connected. And then when you look at the logical topology, it shows you the actual subnets in use. So they're different, slightly different. You can see the server room is all together here. When you look at the logical topology, you see how it's broken up into different individual subnets or individual networks. And we'll talk more about what a subnet and what a network is as we move forward. But there is a difference between how you physically lay your infrastructure out and how you logically design it. We're in the process of a big data center project, and we are actually redesigning the logical topology. So, of our data centers, we're having to do that. So, again, I've already gone over this, types of LANs, MANs, WANs. MAN is a metropolitan, wireless LANs. It's always funny because when you say a wireless LAN, it's really not wireless. It has wireless components. Right. So you see here, obviously there's wireless components for this, but it is wired to something. Now you can have a ad hoc wireless LAN where you connect 2 devices together, say used to be like 2 DSs, and it wouldn't have an ad hoc network. We also talk a little bit about a storage area network, which is a specialized network designed to be in the data center to do your storage traffic on the back end. So limited area network, a single building or campus or home. Wide area network has no geographical boundaries. The best example of that, of course, is the internet. And then intranets and extranets. Obviously, intranets are within the company. Extranets are between the customer and a company. The bad thing about extranets is that you're putting your security at the mercy of your extranet customers, because if you trust someone, trust them, and then they are compromised, then they have access into your network. The compromised network does. Different types of connectivity. These are all common for you. Cable, DSL. Now I will say this: did anybody see? Keep them on mute so you can talk here. Did anybody see the fact that Verizon streamed the Super Bowl in VR over 5G? Anybody see that? 5G will possibly make cellular service, if they can make it work, it may be that it is going to be finally the cell system that will take away the need for even cabling.
Yeah, that's definitely going to happen. I actually work for cellular cells, and we're a Verizon partner, and so that's the big talk right now.
Yeah, 5G is going to be happen. The speeds are insane.
It's crazy.
Isn't there some sort of discussion, though, over who's going to regulate that?
There's always that discussion.
Yeah, well, no, I know, but isn't there supposed to be like that may be regulated by the government, at least to the providers?
Right now, I have no idea. All I know is it can't roll out fast enough, because the sad thing about my house is the wireless 4G signal is like 10 times faster than what I can get through my DSL line. And that's insane.
DSL. I'm on 4G unlimited with AT&T out in the sticks. I finally got to drop satellite.
Yeah. What kind of throughput are you getting?
About 12.
Well, so I get about 11 megabits per second on my DSL, and you know I can get 28 to 40 on my 4G on my phone, depending on you know time of day and where I'm at in the house. So
I'm about 2.5 miles out from the closest tower, so
yeah,
quite a bit of degradation.
What aggravates me the most is I am literally a quarter mile from where the spectrum line ends, to where all they had to do was run it with a quarter mile, and I could get like 100 to 200 megabits per second. It's aggravating, but it's the advantage is I live in the sticks, so I can, you know, I don't have to worry about anybody being right on top of me.
I can see Xfinity's cable where it ends, and we're actually marked off, but they're out of IPs for that subnet is their excuse, and it's not worth the cost for the 10 houses.
I tell them, give me one IP, I'll do it myself.
Yeah, give me one IP, I'll just NAT
give
everybody.
me one IP, I'll NAT everything and make it work. Oh, goodness. So business internet, you've got your dedicated lease lines, Metro Ethernet, which is just running across dark fiber right now, and DSL and satellite, if you happen to do that. A lot of military applications for satellite. Now, one of the things you will see here when we look at separate networks, back in the old days, we did have a data. We had a phone network, and then we had a network for video. Now what we do is we put it all in one network, and we have to have a way of segmenting the information, putting it out on the wire, and then re-segmenting or there we go, been hit by a truck, putting it back together on the opposite end. And we'll talk all about that. We'll look at some of the things we need with network architecture, like fault tolerance, which you can do fault tolerance. And one of the things I always tell people is I can give you the most fault tolerant, scalable network and secure network on the earth, but it's going to cost you. The other thing is this: no amount of security will ever completely secure your network. Everything can eventually be broken into. The only completely secure computer would be one put in a vault, wrapped in concrete, dropped in the middle of the ocean, and even then somebody could go down and pick it up with a sub. So if someone's willing to put the money forward to do it, they will eventually break in your network, period. I firmly believe that. But we do try to have fault tolerance, scalability, security, and a quality of service, especially with the quality of service is huge as we move to these converged networks where voice, video, and data all exist on the same network. So fault tolerance, looking at redundant links, redundant outside links to the internet. Scalability looks at how easy it is to add an additional segment or additional users. Designing your IP addressing scheme with the idea that you will have expansion, which obviously Xfinity didn't do when they went in and built their network. Otherwise, they would have thought about that. So, you know, you think about 10 customers, that's a lot of money that they're losing. And that's all because they didn't build their network to be scalable. Quality of service, very important once we start getting into IP phones. The need for IP phones to have priority, or phone traffic and video and voice traffic to have priority over data traffic. Doesn't matter if your web page loads just a little bit late, but if the voice call has stutters in it, there can be a big misunderstanding. I really don't think I had spent a lot of time discussing security with you and how important it is, but confidentiality, keeping what shouldn't be read unread, making sure integrity is not changed in transit, and then last but least that it's available. We have all been part of these huge break-ins that have been going on with different networks, and it seems like it is constant and unending. What are some trends? BYOD, taking your phone to work, everything else to work. Online collaboration. All right, here we are, folks. I mean, we're spread all over the place in this class. And we're sitting here talking with one another, having class, being able to communicate, which is really neat. Cloud computing, putting everything up in the cloud, which we're all doing. Video conferencing, obviously that's a big thing. Cloud computing, everything from custom clouds to public clouds to hybrid. Palo Alto just had a big discussion and big thing last week about their cloud security platform, how they're trying to roll their Palo Alto Networks firewall information and items into the cloud so they can run it locally on premise and also still have those same policies go up into the cloud that you're using. I'd say the other thing, obviously smart home, that's a big thing. Power line networking. This is something that I totally dismissed for a long time until I had an instructor who was from New York City. And he said, you know, this is the only way I can get internet in my house that works because there are so many other apartments beside me with wireless that there are no free wireless bands. So I use these to have wired connections across my apartment. And I was like, huh, okay. And I'd always dismissed it because, you know, most of the cows around me don't have Wi-Fi. So I don't have to worry too much about that. Here's that wireless broadband where we're getting into hopefully seeing 5G service to houses where we will have super fast connectivity with low latency. That's even better. All the different security threats out there, huge number of threats are going around due to exploit kits, drive-bys, drive-by infections, zero-day attacks. I read today about a zero-day attack using Flash. There's a big vulnerability in Cisco ASAs right now that has to be patched. It actually deals with a large amount of different parts of the ASA. And then different solutions, antivirus, firewall filtering, IPS, VPNs, also next generation firewalls. So firewalls that are using more intelligence than we've seen in the past. Now, here's a little bit of what I call Cisco marketing, but they used to do a lot more of it, talking about Cisco network architecture. We'll talk a little more about it, but right now, just be aware they've got their own. And what we're going to do, we want you to get your CCNA. After the first 2 courses, the ICND1 will be available to you so you can take your CCENT. So you take the intro course and the routing switching essentials. At the end of routing switching essentials, you're going to make higher than a 75 on the final, and you'll get a 70% off voucher for the first test, the ICND1. So that's something I want you to get when we get through routing switching essentials. You will then move on forward, and after you take scaling and connecting, you will get a voucher to do the ICND2, and you will have your full CCNA. Folks, that is all of Chapter 1. Are there any questions from anybody about Chapter 1, about what we're doing in the class, how things work, anything at all? Now I'm going to stop the recording real quickly.